Our code school is about to start, so I just wanted to introduce an Ethereum project called 0x. I've been involved with them as an advisor, and just as a bystander, I've been really excited to see all the work that they've been doing. So 0x is a protocol for decentralized exchange of Ethereum tokens, and they're going to talk about why they think that's so important. So without further ado, please give a warm welcome to Will Warren, one of the co-founders.
Hello, thanks for having me. Thank you, Linda, for the intro. So we're 0x, the protocol for trading tokens. Just a quick overview of who we are and who's involved in our project. Our team is now 5 people. Amir, my co-founder, and I started this project a little under a year ago. And we've put together a great team of advisors and partners and investors. And I want to thank Coinbase for sharing all of your brain power with our project. The advisors that we've gotten from this company have been very insightful. An overview of the presentation. So I'm going to kind of motivate the problem that we're trying to solve and give a quick overview of the ecosystem on the Ethereum blockchain today. I'll show you a little bit of the existing work that has gone into decentralized exchanges prior to 0x coming into existence. I'll explain 0x protocol from a sort of a high level but still technical standpoint, how it works, the different parties involved that make the network work. I'll show you 0x OTC, which is our very first sort of user-facing product that you can go and play with today. And then I'll share with you kind of our timeline, what we've been doing up until this point, and where we plan to go in the future. So the world is becoming tokenized. Today there are already over 20 ERC20 tokens on the Ethereum blockchain, and their combined value is over $2 billion. There's also hundreds of decentralized applications that exist today. But in our view, by 2020, there will be many thousands of tokens on the Ethereum blockchain, representing a range of assets from traditional securities like stocks and bonds to fiat currencies, all the way to scarce digital goods like video game items, airline miles, loyalty points. All of these will be tokenized. And when that happens, the value of all tokens will be in the range of tens to hundreds of billions of dollars. We also think that there will be many thousands of decentralized applications, each with their own token. And naturally, there will be a strong need to be able to exchange these tokens. So the current ecosystem on the Ethereum blockchain, there are already a handful of decentralized exchanges that exist today. And there are also a bunch of different decentralized applications that require exchange functionality in order to operate, like prediction markets, decentralized asset management platforms, stable coins. The issue is that each one of these existing projects use their own custom and proprietary smart contracts that they build from scratch. And this means that each single project has to bootstrap liquidity from scratch, which is a very hard problem to solve. They each have sort of different levels of efficiency and security, different learning curves and configuration processes. And what this means is that for the end user, you have to trust many different smart contracts with your valuable digital assets when all of these smart contracts do the exact same thing. So it creates this unnecessarily large attack surface. And probably the biggest problem is that there's no interoperability between any of these different exchanges that are used among these different projects. So our thesis is that smart contracts should act as modular, unopinionated building blocks that can kind of be assembled and reconfigured. And we also believe that open standards tend to win out in the long run. So now I'm going to cover some of the existing decentralized exchange implementations that people have explored in the past. The very first decentralized exchange built on Ethereum kind of mirrored a centralized exchange in that it took all of the functionality of a centralized exchange and pulled it into an Ethereum smart contract. So what this means is that the order book, so the list of bids and asks, people that are trying to buy or sell a different asset, are actually stored within a smart contract. So what this means is that every time a market maker or someone trying to place a trade either wants to create an order, modify an order, or cancel an order, they must pay a transaction fee to sort of cover the gas costs of updating the state of that smart contract. So that's prohibitively expensive. There's just absolutely no way that a market maker in sort of a centralized, like traditional markets would be able to operate in a decentralized exchange that operates with a on-chain order book. Another issue with on-chain order books is that they bloat the blockchain. So you can imagine if you place an order on this on-chain order book and you decide that, hey, I want to slightly adjust the exchange rate that I'm willing to accept, you know, the blockchain has to remember your previous order, it has to remember the adjustment that you made, and all of this has to be stored on thousands of computers all over the world for eternity. That's not a very efficient way of using the blockchain. The third issue with on-chain order books is that they have high latency. So you have to wait a single block time or more in order to have your order show up on the order book. And same thing happens when you're trying to update your orders or fill orders. So Maker Market you can use it today. It's one of the very first decentralized exchanges on Ethereum that actually sees a lot of use. I've actually personally used it to trade some tokens, Ethereum tokens. It uses an on-chain order book. They've changed the name of Maker Market to Oasis Stacks. Augur, the very first implementation of Augur's exchanges will also use on-chain order books until they move over to 0x in the future. Oasis is also considering moving onto 0x in the future. So automated market makers are the second class of decentralized exchanges that exist on the Ethereum blockchain. And how an automated market maker works is that instead of two counterparties on opposite sides of the market trading directly with each other, each party trades with an Ethereum smart contract. And the price that they get is determined, it's a deterministic relationship between spot price and buying and selling pressure on either side of the market. And so this was sort of the approach that Augur and Gnosis first attempted to use for their prediction market exchange. But what they basically found is that if you have an equation, a math equation, determining how your prices will change with respect to market forces, it doesn't create very efficient markets. And for example, if there is a large buyer and a large seller that are trying to facilitate some sort of exchange, if they have a lot of assets, they can't just pass them through the automated market maker. They have to sort of break up their trade into small chunks and go back and forth with this automated market maker. It's very expensive. So Augur and Gnosis both abandoned this plan. Gnosis did release a blog post saying that, what is really cool about automated market makers is that what you do get out of them is an on-chain price feed. So while you might not be able to trade very efficiently with a market maker, automated market maker, you do get a price feed that's directly on the blockchain, which is kind of cool, but not that useful for exchange. Bancor is actually an automated market maker. It's slightly more sophisticated. In a traditional automated market maker, you're trading on one market and the spot price adjusts. But with Bancor, if you trade on one market, this can affect the prices of other markets. So it's a little more sophisticated. We'll see if it works. The third type of exchange implementation that has a lot of potential are state channels. So state channels, essentially what you do is you lock up the assets that you want to be transacting into a off-chain channel, and you can accumulate many intermediate state changes off of the blockchain with a counterparty, and then you sort of roll all of these state changes into a single transaction that you settle directly on the blockchain, kind of like a bar tab. So this is really good for things like day trading. So if many small trades throughout the day, it's good for things like poker. You can go sit down at a poker table with the funds that you want to be playing with. You can play hands of poker back and forth. When you're done playing, you settle back on the blockchain. So another great thing about state channels is they're very high throughput and low latency because you're not limited by the block time of the Ethereum blockchain. So you can do things that more closely mirror a centralized exchange with like potentially even things like high frequency trading and stuff like that. One issue with state channels is that if you want to make a single trade, you need multiple transactions on the Ethereum blockchain. So you have to move your funds into the state channel. You have to move a security deposit into the state channel. You have to close the state channel when you're done trading, and you have to wait for a challenge period to pass to basically it ensures that every party that is within the channel is behaving honestly. So if you just want to do a single block trade, you want to sell some Ether, you might need to do many different transactions on the Ethereum blockchain, which is not very efficient. Two other problems with state channels. They're vulnerable to DDoS. So if you open a channel, do some trades, and the counterparty decides to DDoS you, they can kind of lie about the outcome that you reached in the channel and steal your funds. So that's not a good thing. Another issue is that since all of the actions that are occurring within a state channel are completely isolated from the Ethereum blockchain, you can't actually interact with smart contracts and all of the sort of capabilities they provide, which is a limiting factor. So how does 0x work? 0x uses something called off-chain order relay and on-chain settlement. So essentially how it works at a high level is you define the orders that you want to make, the order parameters, such as the assets that you want to trade, the exchange rate, the counterparty potentially, and how long you're willing to honor this trade or this order. You take this chunk of data with all these parameters and you cryptographically sign it with your private key, and you do all this off of the blockchain, so it doesn't require a transaction. You broadcast this cryptographically signed chunk of data to your counterparty, and if they are happy with the exchange rate and they are willing to be your counterparty, they will take the chunk of data and the cryptographic signature, they will inject it into a smart contract on the blockchain, and assuming the cryptographic signature is authentic and the order has not expired and both parties have sufficient funds in order to carry out the trade, the smart contract will then move the funds between the two counterparties. So that's kind of what you see here. This is a diagram from our white paper. It sort of outlines a series of steps involved in taking a chunk of data that represents an order, signing it, broadcasting it to your counterparty, and settling a trade. So what's interesting about this is that there's no constraints placed on how you transmit this chunk of cryptographically signed data to your counterparty. You could send it through Facebook message, you could send it through email, you could take an order and you could broadcast it on Twitter, and anyone that sees it could inject it into the smart contract and settle a trade with you. So this is a really powerful method. It requires a single on-chain transaction to settle a trade. So there are a couple projects that figured out how to use this off-chain order relay and on-chain settlement approach around the same time that we did. Ether Delta is one, and IDEX is another. Now the issue with both of these projects is they create their own custom smart contracts that allow you to do this type of exchange. And what this means is that every trade that goes through the contract automatically extracts rent for the person that owns the contract. So it's quite limiting, and it's proprietary. So what is 0x? We take this off-chain order relay and on-chain settlement, and we turn it into a protocol that anyone can use to trade directly with a counterparty for free. And it also allows anyone to be the exchange. Anyone can create sort of an off-chain order book where people can send them orders, pay them transaction fees for offering that service, and it sort of democratizes who can be the decentralized exchange. So in layman's terms, 0x is a publicly accessible system of smart contracts with a formalized message format that lays out how an order needs to be structured. So this diagram here shows exactly how an order needs to be structured. The order has a version which points to the Ethereum contract that actually settles trades. It specifies the two assets that are being traded. It can be any asset, any ERC20 token on the Ethereum blockchain. It doesn't care who is originating the order, sort of the total value of each asset that's being exchanged, the expiration time in Unix seconds. So if you want to create an order that will remain valid for 10 minutes, you can do that. If you want it to remain valid for longer, you can do that. And it also specifies a fee recipient. So I'll explain this in more detail later, but this is what allows anyone in the world to operate a shapeshift or a trustless shapeshift. So relayers. Relayers are what we refer to as decentralized exchanges, essentially. So an exchange kind of creates its own proprietary infrastructure, and it acts as a custodian for each person trading, and they really kind of own the whole system. While with 0x, no one owns the system. It's owned by everyone, and it's publicly accessible. So the people that are operating these exchanges, they're really just relaying these cryptographically signed messages. So we refer to them as relayers. So a relayer is any party that hosts an off-chain order book and collects transaction fees for offering that service. So how a relayer will sort of interact with two parties that want to make a trade is the relayer, someone will go to a website, they will say, I want to place a trade on your order book, and the relayer will say, okay, this is my fee schedule. You will need to pay me this fee in order to use my order book. If the fee is acceptable to the person originating the order, they will say, okay. They will create this cryptographically signed order that specifies the fee recipient to be the relayer, so that once the trade is settled, the fees go to the relayer. They will specify the fees to be values that the relayer is willing to accept. They take this cryptographically signed data packet and they send it back to the relayer. The relayer makes sure that they are in fact getting paid transaction fees, that the fee values are sufficient, and assuming everything is good to go, they will add that order to their order book and broadcast it to the entire network of people that are trading. So just to reiterate, during that whole process of interacting with the relayer, there is no trust involved. So the parties on either side of a trade, they never have to give over control of their funds to the relayer. They never have to trust the relayer to behave honestly. And there is no way for the relayer to take advantage of the people that want to place orders on their order book. And it's in the best interest of the relayer to sort of maximize the number of orders that come onto their order book, because they earn transaction fees for each one that ends up being settled in a trade. So what's really interesting about 0x as a protocol is that it allows other smart contracts on the Ethereum blockchain to programmatically execute trades in a single line of Solidity code. So essentially what this means is that in the future, decentralized applications can become more sophisticated over time because smart contracts can actually execute trades. So this kind of goes beyond the model of just operating a decentralized exchange for the purposes of just trading different speculative assets. It actually allows smart contracts to begin to do more sophisticated things. And another thing that's interesting is that decentralized applications or smart contracts, they can pull liquidity from any of these sort of off-chain liquidity pools that are created by relayers. So it's an entirely an entirely new customer for these exchanges that wasn't there before. And so sort of to give an example of what this capability might look like in the future, once we sort of fully realize the different types of decentralized technologies that make up the DApp application stack. In the future, a fully decentralized application, it might require things that a normal application requires: file storage, computation. It might require something like a dispatcher to trigger something to occur at a specific time or under certain conditions. And if you're an end user of this decentralized application, you don't necessarily have interest in holding on to a bunch of different highly volatile, highly speculative assets. You just want to access the decentralized application. So what you might end up doing, or what this DApp might end up doing, is it might accept USD fiat tokens, or whatever fiat is used by the person using the DApp. It will use 0x to purchase 0x tokens, which will then be used to fuel further trades to purchase these other tokens, like Filecoin, like Golem, like Snow, which hasn't released a token yet. And all of these tokens will be consumed by the DApp outside of the view of the end user, and it will sort of power all of these different subsystems that make up the DApp. And the DApp will end up providing whatever sort of utility that the end user was expecting, but the end user doesn't really know or care about what's going on underneath the surface. From their point of view, they just sent a few dollars of fiat tokens, and the DApp worked. So I mentioned ZRX tokens, or 0x tokens. So 0x token is used for two different things within the 0x protocol and the system. First and most importantly, ZRX is used for decentralized governance over upgrades to 0x protocol over time. And why this is important is because 0x is a system of Ethereum smart contracts, and Ethereum smart contracts are immutable. Once you deploy their business logic to the blockchain, that logic can never be changed. And simultaneously, these Ethereum smart contracts exist on a rapidly evolving technology stack. So Ethereum is changing sort of at the base protocol level with Casper coming out, proof of stake. It's changing at the EVM level, so new capabilities are being programmed into the virtual machine. And it's also changing at the smart contract programming level, where smart contracts are being given the capability to do new things over time. So if 0x, if the smart contracts that make up 0x protocol were never able to be upgraded, it would quickly sort of lose relevance, and all of the different, all the different exchanges that are built on top of it, all the dApps that plug into it, they would quickly fork off the standard, and they would create 0x plus some feature. And what would happen is all of these different forks would sort of fragment the liquidity pool and all the benefits, all the network effects around liquidity that are gained by sharing a standard and a shared settlement layer would dissipate. So there needs to be a way to upgrade these smart contracts over time. So the way that 0x smart contracts are structured, there are different modules. So in this diagram here, you can see the exchange smart contract, which is, it contains all the business logic associated with accepting these ordered data packets, authenticating signatures, ensuring that each order has not expired, and actually moving assets between parties. And that's the logic that might need to be swapped out. And then there's also a governance smart contract. And the governance smart contract is what allows people that hold the 0x token to sort of vote on upgrades. So how do we want to swap out the exchange contract for a newer version that includes new features and improvements? And it can, essentially this update mechanism can allow the system to be upgraded without disrupting all of the markets and exchanges and like sort of hard forking the network. The second use for the 0x token is to pay these relayers transaction fees for hosting and maintaining these off-chain order books. And sort of one of the sort of strongest incentives I would say that this provides relayers is that they can purchase these ZRX tokens with sort of this information edge that they know they are building a useful application on top of 0x, and they can build an exchange, build an application, what have you, and they can increase the utility of the token directly. So in effect, they have some sort of influence over the price of the token. So as a counterpoint, or sort of as an example, imagine you're a mobile developer and you create an iOS application, but before you deploy that before you release it to the public, you buy up a bunch of Apple stock. Unfortunately, Apple is so big that no one would really care. All the stockholders, all the shareholders, they wouldn't really care about your single iOS app, and you probably wouldn't really affect the price of Apple stock. So it wouldn't work that well. But if you were to buy up a bunch of ZRX tokens and you have a large influence over the network and its utility, then you can go build something super useful and you can directly influence the utility and therefore price of the token. So I mentioned 0x OTC. So 0x OTC is the very first user-facing product that we've built on top of 0x protocol. So 0x protocol is fully functional. It's deployed to the testnet, Ethereum testnet called Kovan. You can go and use it today, and 0x OTC might be the way that you do that. OTC stands for over-the-counter. So if you want, you can sort of generate an order, data packet, cryptographically sign it, send it to a counterparty, and execute a private over-the-counter trade. So I'll show you a GIF of what that looks like. Let's wait for it to restart. Here we go. So here we see someone, they want to trade some Augur reputation tokens for Melon tokens. They specify the exchange rate, the time at which the order will expire. They cryptographically sign this order with their private key using MetaMask. It pops up with this JSON object, which is the order, it's the cryptographically signed order, and then they go and share it on Twitter. So you can go and check this out right now. It's at 0xproject.com/OTC. And this GIF does not appear to be working, but what this shows is the other side of the process. Someone receives an email with the 0x order. They open it up on 0x OTC and they fill the order. You can, kind of look at your trading history and you can inspect the order on Etherscan. So timeline and roadmap. Amir and I began working on 0x back in October. We released the white paper in February. We deployed our contracts to the testnet in March, and we launched OTC not too long after. Fabio and Leonid have been working on 0x.js, which is a JavaScript library that allows web developers to just essentially build web apps and directly plug into 0x protocol. They don't have to have any technical knowledge on Ethereum. They can immediately start using the protocol, executing trades. And we just kind of quietly released that in our GitHub repository. We're in the process of getting our smart contract security audited. And once we are positive that our smart contracts are safe, we will be deploying them on the Ethereum mainnet very soon. And then on August 15th, you heard it here first, we'll be launching ZRX token. And people will be able to begin using 0x protocol in the network. And after that, we have a long development roadmap that you can go check out online. And you can track our progress at 0xproject.com, Slack, Twitter, GitHub. And that is my presentation. So thank you. Questions?
How do partial fills work?
Partial fills work exactly as you would hope them to. You can partially fill an order, and any remaining amount of the order that hasn't been filled can then be filled by a future trade.
So is there anything to stop someone from filling an order that's not like at market price, like buying at something above market rate or selling?
No, there isn't. So if someone offers to sell you something at a very bad price, a very bad exchange rate, you can, in fact, go and execute a trade with that person at a bad exchange rate. But another sort of relayer strategy that we didn't present here is we call it sort of like a centralized matching engine. So the relayer can take orders from each side of the market, and those orders specify the relayer as the only entity that's able to actually fill those orders. And then the relayer will find orders on either side of the market that overlap, and they will batch fill them synchronously in a single transaction. So in effect, you can kind of emulate market orders through this centralized matching engine process.
A couple questions. I just want to make sure I'm understanding things correctly. Let's say I'm writing a DApp. I'm the author of like an actual Ethereum contract, and I want to use 0x. So I want to, like your example, I want to accept Tether tokens and use that to participate with other contracts. Do I have a sort of account with the 0x structure where I have these tokens locked up and then I'm trading them?
Yeah, so actually that was a decision that we thought a lot about, and you don't. So if you just have an Ethereum wallet, you just provide approval to the 0x smart contracts to pull specific tokens and specific amounts of tokens from your wallet. And
how?
So ERC20 tokens, they have a few different functions. The function that people are most familiar with is probably the transfer function. So the person that owns a balance of tokens can send those tokens to someone else. But ERC20 also includes two other functions, approve and transfer from. So if you have a balance of rep and you want to use a dApp that needs to access your rep, instead of sending your rep to the smart contract, instead what you do is you provide approval, and then that contract will pull the rep in. So smart contracts kind of use a pull rather than push model when it comes to moving tokens.
I have another question. If there's time here you go. A little later.
You mentioned that you don't need to trust the relay in this scenario. How can you prevent the relay from just pulling your money and not giving you anything back?
Right. So the only reason you would ever want to provide an allowance to a smart contract, provide access to your tokens, is if you can directly inspect the source code and see exactly what it can do with your funds. So relayers have no access to your funds at any point in time, but the 0x smart contracts do, and you know exactly what the 0x smart contracts can do. Yeah.
If I understood you correctly, you said the relayers can actually pool liquidity by, I guess, looking for other relayers or other exchanges out there. Is that correct?
Sorry, I couldn't hear you.
Well, you talked about pooling liquidity, and how exactly was that done first?
Right. So there might be different exchanges with different order books, and it doesn't matter where you pull an order from. If you want to sort of trade some USD token for some Filecoin or whatever, an ERC20 token, you can sort of pull an order off of any order book you want. And I was just sort of referring to these centralized order books off-chain as liquidity pools.
Got it.
Yeah, maybe that was confusing to use different terms.
Well, so I was wondering then, obviously this is hard to know the future, but what's, in your mind, the steady state of how decentralized, in the generalized sort of definition of the word, these relayers will be? Are there economies of scale where certain relayers will be more, I guess, will have thicker order books, or if you can actually, tap into other order books with no friction, does everyone eventually run an exchange themselves?
Yeah, that's an interesting question. So, two answers. So, liquidity tends to concentrate in centralized locations because of network effects. Like, the more liquidity in a centralized location, the higher probability you can get a good spot price. That said, we're massively lowering the barriers to entry for new people setting up decentralized exchanges. So, and you can take an order on one exchange and take an order from another exchange, and you can sort of batch fill them. So you can arbitrage across different exchanges, which it kind of reduces the switching costs between different relayers. So honestly, I'm not really sure what the answer to that is. If it'll just be sort of for a specific market sector, if it'll be one relayer that kind of dominates everything, or if it'll be really competitive and there'll be different relayers, I'm not sure. Another thing to point out, there will probably be relayers that focus on very specific industries and like different demographics. So right now, like Coinbase is maybe for like the more casual user, whereas GDAX is for institutional traders. And I can imagine relayers that, they kind of vary by UX. They also vary by market. So maybe prediction markets or are sort of their focus, or just like creating a shapeshift like user experience is something that sets them apart, something like that.
So I wanted to ask you about like whether you can elaborate more into the governance model. So like, let's say, there's a malicious party that owns a lot of, 0x tokens. Could they then, update the smart contract at 0x and then like pull out all the funds from all the wallets that like approve transactions to 0x?
Yeah, they could, but only if the decentralized governance system is very poorly designed, which is actually why we have not released a V1 governance system. We're going to have a placeholder, which is essentially like a multi-sig, and it's a bunch of different people with different interests in the protocol being successful, and they will sort of, this multi-sig will transfer ownership of governance over to a DAO once we have a DAO that we're comfortable with. Creating a decentralized governance system is a really challenging problem with a huge attack surface, and sort of our primary goal was to make a system where people could start exchanging tokens really easily and lower the barrier to entry for doing that. Governance is an important part of the system, but it's also a much harder part to design well. So that's something that we want to spend a lot of resources researching.
Yeah. Cool. Just to follow up to that, like as we've seen from BAT and I guess what was the other one? Status. Like, do you have any plans on how to, get rid of that sort of holding, like centralized holding of the tokens?
Oh, like for the like
KYC
how the tokens are concentrated.
Yeah, exactly.
Yeah, we have some interesting ideas, but I don't think we can talk about them yet. All right. But yeah, so that's like a top priority for us. In this current, in the right now with all the like token launches going on, you can raise funding to build your product, but that's not the important part about a token, allowing you to raise money. It's part of the utility. But really what a token provides is it allows you to bootstrap an ecosystem of people that want your project to succeed and contribute to it. So we're extremely motivated to figure out a good way to get our token into the hands of as many people as possible. And that's all I can say.
Thanks a lot.
Thanks for being so careful with the governance and getting a security audit. That's awesome. Can you expand on the importance of a relayer being a centralized entity, and why isn't there just some gossip network where people are propagating their intentions to buy or sell and just matching on their own machines as part of that network?
Yeah, so the short answer is that creating a relayer that's centralized is the sort of the path of least resistance for now. So if you can work with 0x.js, set up a web server and a database, you can be a relayer, and you can start earning transaction fees. In the future, but it's centralized, and you could get censored. The government can shut you down. That's not ideal at all. So phase 2 of the project, which we don't talk about very much because it can distract from our primary goals, is to create a relay protocol where it's a swarm of nodes that are propagating this decentralized order book. And each node in the network essentially gets tokens paid out to them in proportion to their contribution in propagating this order book. But that's a much harder problem to solve, and that's probably like a multi-year research project. Yeah.
Awesome. Thanks.
Am I understanding it correctly that every order is settled to the chain?
Correct.
Okay. So it definitely seems like that, I don't know, do you think that scales, like, how do you plan on, like, I don't know, improving the scaling of that down the road if this was to reach, like, global penetration?
Yeah, so, again, like the short answer is that throughput, so trading activity, like throughput, is constrained by the Ethereum blockchain. Scaling the Ethereum blockchain is a hard problem that fortunately we have a bunch of really smart people working on. I think it's something that we would also like to contribute to in the future when we can grow our team and have more resources. But one of the things that we can work on is we can reduce the gas costs per trade. And another thing we can do is make exchange as efficient as possible. And I think we've already kind of made a lot of progress on doing that. But yeah, I mean, scaling the Ethereum blockchain is going to be a hard problem, but there's already some like pretty good solutions on the horizon. So
cool. But like, okay, so you're just intending to scale this like alongside the Ethereum blockchain and not like have an independent 0x scaling solution? Yeah.
So I mean, since 0x consists of a system of Ethereum smart contracts for settlement, and all trades are settled on the Ethereum blockchain, we're just limited by throughput of the Ethereum blockchain. The reason why, we feel like it's really important to settle trades on the blockchain is because it allows for cool stuff like smart contracts executing trades, stuff like that. For things like really scalable exchange of tokens in a decentralized way, I think state channels will probably be really important for that. But I also think that scaling is, that's like the top problem people are trying to solve. And yeah, I mean, people are going to be making progress on it all the time. So. Yeah, soups.
So I had a question. So if I wanted to build a Poloniex-like exchange, what would I have to do with, let's say, using the 0x protocol right now? versus if I had to go the traditional route of, building an order book, et cetera, et cetera. Like, are you thinking of like providing building blocks for someone to actually build an exchange in the future as well?
Yeah, that's exactly right. So we want to lower the barrier to entry as much as possible. So did you ask how hard it would be with 0x compared to building a centralized version or building a decentralized version from scratch?
A centralized one, let's say.
Oh, yeah.
If I wanted to enter the ecosystem and build a Poloniex competitor, let's say, as opposed to like take a decentralized approach and use the building blocks you're providing, so which one would be easier, and what are the steps I would need to take? I'm just trying to think of your thought process over there.
Yeah. So I would argue that Poloniex probably has an insanely complex back end compared to 0x smart contracts. And building all that infrastructure is probably a lot harder. You probably need a team of engineers. Again, like you're building all of this centralized infrastructure from scratch. That's not an easy problem. With 0x, essentially you would include 0x.js as a library, and your back end is the blockchain. Part of your back end is the blockchain. Part of your back end is sort of a database that stores orders, and you would serve that to a front end. And I think it would be something that you could do in ideally you could do it in like a week to get to like MVP. But maybe that's a year out from now, something like that.
I guess security is a main thing that you don't have to worry as much about because you're not holding user deposits.
Yeah, so Fabio said security is probably one of the biggest advantages that you get with 0x built in, because with Poloniex, you have to build all the security yourself, which is, this is a really good point.
Another question, so with these OTC trades, how would the price, I'm assuming the price would be impacted. So two-part question. So does 0x provide a way for me to also query the price, for any token as it is tied to, let's say, ETH or BTC? And the second part, how does an OTC trade affect the price on an exchange?
So the way 0x works, kind of at the fundamental level, is it allows you to create limit orders. And the way that you can sort of see the spot price of a trading pair, if you're just looking at 0x orders, is probably to just like organize them according to exchange rate and find the best price. It's probably, I would say like 0x orders are probably not like the ideal solution for like creating a price feed. But I could be wrong. And how does an OTC trade affect prices? You mean like if you do an OTC trade, does that affect the price on an exchange somewhere else?
Yeah.
No, not at all. So completely separate. Every single off-chain transaction is sort of an isolated incident. Yeah. Thanks for the questions.
Thanks. Yeah.
Let's get lunch.